Hello everyone, welcome to my channel. Today I'll be talking about the 4 quantum numbers. What are the 4 quantum numbers? What are shells? What are subshells? What are orbitals? Let's get started. The first quantum number I'll be talking about is the principal quantum number. The principal quantum number. The principal quantum number. Quantum The principal quantum number is the quantum number that describes the energy level or the shell around the nucleus of an atom where electrons can be found. From Bohr's theorem, Bohr predicted that the electron revolve around the nucleus of an atom, electron revolve around. So that part whereby the position whereby electron revolve around the nucleus of an atom is what Bohr calls the energy level or the shell. The energy level or the shell. So the principal quantum number is denoted by letter N, and is positive integer. Positive integer. N could be what? N could be equals to 1, could be 1, could be 2, could be 3, could be 4, like that. So this quantum number describes the energy level or shell where electrons can be found around the nucleus of an atom. So let's say this is the nucleus of an atom. This is the nucleus of an atom. So this point where electrons revolve around is called the energy level. It's called the energy level or the shell. It's called the energy level or the shell. So when N equals to 1, it is describing the K shell. So this is pointing to the K shell, the first shell after the nucleus, the simplest energy level. So when N equals to 2, we have the L shell. The L shell. When N equals to 3, we have the M shell. M shell. When N equals to 4, we have the N shell. We have the N shell. Therefore, N starts from 1 down to 4. N starts from 1 down to 4. So this is the first quantum number. The closest shell to the nucleus of an atom is called the K shell, followed by the L shell, M shell, and lastly the N shell. So that is it. The second quantum number we're talking about here is the Azimuthal quantum number, denoted by letter L. It describes the subshell of the main shell. That's subdivision of the main shell. And there's a relation between the principal quantum number and the Azimuthal quantum number. L is greater than or equal to N minus 1. L equals to or greater than N minus 1. So when N equals to 1, remember the formula. So when N equals to 1, so D equals to L equals to or greater than what? 1 minus 1 is 0. So when N equals to 1, our L equals to 0. And that is describing the subshell of K shell. That's K shell. Subshell of what? Of the K shell, which has only one subshell, which is S. So when N equals to 2, remember our L again equals to 1 or 2 minus 1, which equals to what? 1. So our L equals to 1. Our L equals to 1, and this describes or points to what? To the L shell, which have two subshell, S and P. All right, so when n equals to 3, we have our L, which equals to what? 3 minus 1, which equals to 2. So our L equals to 2, which is pointing to what? To the M shell, which has 3 subshells, S, P, D. Now, when n equals to what? 4, we have L to be equals to what? 4. This one is L equals to 3 minus 1. L equals to 4 minus 1, which equals to what? 3. We have our L to be 3. So that's describing the subshell of N shell, which is S. The subshells are S, P, D, F. S, P, D, F. So in brevity, this azimuthal quantum number describes the subshell of the main shell, which are what? Be S, P, D, and F. S, P, D, and F. So that is the second quantum number. The third quantum number is the magnetic quantum number, denoted by ML. M subscript L. This describes the orbital in the subshell. This describes the orbitals now. The first quantum number, principal quantum number, describes the shell, the main energy level. The azimuthal quantum number describes the subshell. So this one describes the orbital in the subshell. This one describes the azimuthal quantum number. This describes the azimuthal quantum number. So it's given by the formula ML ranges from plus L to minus L, from L to minus L. So when L equals to 0, ML ranges from 0 to minus 0, which is same as what? ML equals to 0. This is showing that it has only one orbital. One orbital. When L equals to 1, our ML ranges from 1 to minus 1. From 1 to minus 1. So we have it to be what? ML equals to 1, 0, and minus 1. That's 1, 2, 3. Three orbitals. When L equals to 2, we have our ML ranges from what? Plus 2, 1, 0, minus 1, minus 2. Therefore, we have our orbitals. We have 1, 2, 3, 4, 5. We have 5 orbitals in this subshell. So we have 5 orbitals. 5 orbitals. Lastly, when L equals to 3, we have what? We have ML ranging from what? 3, 2, 1, 0, minus 1, minus 2, and lastly minus 3. This is how many orbitals in this subshell? We have 1, 2, 3, 4, 5, 6, 7. So we have 7 orbitals in this subshell. So when L equals to 0, this is talking about the S subshell. When L equals to 1, this is talking about the P subshell. When L equals to 2, this is talking about the D subshell. When L equals to 3, this is talking about the F subshell. So the last, but not the least, is the spin quantum number. The spin quantum number. Spin quantum number. The spin quantum number, denoted by mx, describes the direction of the spin of the electron in these orbitals. It describes the direction of the electrons in these orbitals. It's given by mx equals to plus or minus 1/2. That is, when the electron moves in clockwise direction within an orbital, clockwise direction, mx equals to plus 1/2 half. When electron moving clockwise, the direction, nx equals to minus 1 over 2. So, and then the maximum electron that can be in an orbital will be 2 like that. One in clockwise direction, the other one in anti-clockwise direction. And that is why S can take 2 electrons, P can take 6 electrons, D can take 10 electrons, and F can take 14 electrons. That is why S can take maximum number of 2 electrons, because electron was going in one will be direct clockwise and the other one anti-clockwise direction. That is why this can take 2 electrons, this can take 6 electrons, this can take 10 electrons, and this can take 14 electrons. So let's represent S, P, D, and F with a box. So let's say our S have just one box, our P has what? 3 boxes, our D has what? 5 boxes. 5 boxes. Three boxes. 1, 2. So this is it. One, 2, 3, 4, 5. So this can take. This has 7 orbitals. 7 orbitals. 7 orbitals. So it can take. You can see this one can go clockwise, anti-clockwise, clockwise, anti-clockwise, clockwise, anti-clockwise, clockwise, anti-clockwise, and like that. So that's why this can take again 2 electrons. This can take 6 electrons. This can take 10 electrons, and this can take 14 electrons. If you want access to free tutorial video like this and more, please consider to subscribe, turn on the notification bell, so as to be the first person that will get notified when we post free tutorial videos like this.